Okay, number 11 is a negative cosecant wave. It looks like we're supposed to graph from 5 to 35, which means no pi's involved, which is why we have pi's in here, because things are going to simplify out. Okay, so first off, there is no shift up or down, so that means the x-axis is my midline. However, we do have a negative 3/2 up front, so let's just go ahead and do the amplitude for the negative sine wave, if you will, at 1.5 up and 1.5 down. So 1.5 up and 1.5 down. Okay, and then I need the figure out the period. So period for cosecant is 2 pi divided by b. So 2 pi divided by pi over 10, or multiplied by 10 over pi. And what I see is that the period is 20. So if period is 20, then I'm going to do a little graph up here. I'm starting with a negative sine wave. Okay, so a negative sine wave that looks like this, and I'm going to let that be 20, which means that's 10, which means that's 5 and 15. So that's my wave, the sine wave anyway, that I would base the cosecant off of, and then I'm going to figure out phase shift. So phase shift is negative c over v. So negative 5 pi over 2 divided by pi over 10, or multiplied by 10 over pi. Pi simplify out, 10 divided by 2 is 5, so negative 25. So that means go to the left 25. Well, going to the left 25 is the same thing as just going to the left 5, because it's more than one period. So if you think about this, if I were to take this piece that's at 20 and move it to negative 5, right, then this would be, actually the piece right behind it would be right next, right? So do you see how, like, moving this and this 25 over is the same thing as just moving this and this 5 over? So I'm just going to think of it as moving it to the left 5. Okay, so that means that the thing that was at, well, let's just go ahead and move 20, because here's the thing, I'm only supposed to graph from 5 to 35. So if you want to graph over here and use that like to be able to figure out where your points are going to be, that's fine. But I'm going to go ahead and pick points that are after 5 and move them to the left 5. So like this point right here is at 10. That means it should be at 5 now. So let's see. If I let that be 5, 10, 15, 20, 25, 30, and 35. Then the point that was at 10 is now at 5. So I need to be at my center point. So 10 at 5. At 15, I was at my max. Now that should be at 10. And so there is my, that's the beginning of my pattern, and all I need is 2 points to continue the pattern. Now remember, this is my negative sine wave. It's not my cosecant wave, so this is not my answer. I'm going to put it in dotted. Should have done here, and then max, and then come back down, and then stop there. Okay, so to graph my cosecant wave, what I do is everywhere that this wave hits the midline, then I should have a vertical asymptote. So we should have one at 5 and 15, 25, and 35. And then we should have a minimum here, a maximum there, and a minimum there. And there we go. Okay. So I took a negative sine wave and I plotted it out, moving it to the left 25, or just moving it to the left 5. And if you wanted to keep on going, like if you had moved this point right here at negative 5, then you could have seen, okay, if I could do this, then it continues on. And then just started graphing here for your cosecant wave. Okay? I'm not going to count off for you having more of the other wave graphed for you to be able to see what's happening. All right, so number 12. I've got a negative cotangent wave shifted down 3, and then other crap's going on, so let's figure that out. So let's just go down 3, that's my center line. So I'm just going to draw that to remind myself to start there. I've got a negative cotangent wave. Okay. So normally cotangent looks like this, where I've got vertical asymptote here, and I've got vertical asymptote at the period, and then halfway between I go through like this, but it's a negative cotangent wave, so it flips over, so it's going to look more like a tangent wave. Okay, so once I figure out the period, then I can go from there. Let's see. I'm going to go ahead and factor out a negative. Well, no, we'll just go ahead and do this. So period is going to be pi divided by b. And in this case, I'm just going to deal with the 2. The negative is just the reflection, so it's okay to leave it like this. So the period is going to be pi divided by 2, which means that this right here is at 0, and that should be at pi over 2 normally, which would mean this is at pi over 4. So when I look at this right here, 1/4 is this piece right here, and then pi over 2 is this one, and then if I were to go another tick mark, so if I'm letting that be 1 tick mark, that's 1/4, 2/4, that's 3/4 pi. Or, if I let it be every other tick mark, then I could say this is 1/4 is 2 tick marks, and then 2/4 is 4, and then 3/4 is 6. Do I have enough space for that? 1, 2, 3, 4, 5, 6. I do. And that's also nice because this right here is negative pi over 8. And so if the center point is at pi over 4, then that means that point right there is at pi over 8. So that means 1 tick mark more to the left. So if I let every tick mark be pi over 8, so 1/8, 2/8, which is pi over 4, 3/8, 4/8, which is pi over 2, and so there I've got 4 tick marks for the period. If possible, that's what I like to do. And then 1, 2, 3, 4, 5/8, and then 6/8, and 6/8 is 3 pi over 4. And then to the left, pi over 8. So 3/4, and then negative pi over 8. And then let's figure out phase shift. So phase shift is negative c over b. Actually, this is going to be kind of interesting to play around with. So I might have to redraw that right there. I think I am going to factor that negative 2 out. So negative 2, and then theta, it's going to be minus, and dividing by 2, so it's multiplied by 1/2, so it's pi over 4. So I can see it means go to the right pi over 4. I don't know if I want to do this the way that I've got it set up. Okay, so I'm just trying to think about whether or not I want you guys to have to worry about doing that. So, okay, the first thing you would do as far as transformations go is flip over the y. So if you reflect over the y, then this right here would actually flip over to here. So I'm going to play around with that. Normally it would be over here, vertical asymptote, now it would be. And instead of it looking like this, when you flip it, it's going to be over here, and it's going to look like this because you're reflecting over the y-axis. So we reflected over the x and the y, which is actually going to get us back to a cotangent wave, what looks like a cotangent wave, a normal one. And so it would look like that. I hope that's not confusing, but 1, 2, 3. So you can see that if I do this, that is a reflection across the y-axis. So I'm actually playing around with this one right here, which is 0 and negative pi over 2. Okay, so as far as my transformation, I am going to go to the right pi over 4, and I can see that pi over 4 is 2 tick marks. So this vertical asymptote that was a negative pi over 2 should be at negative pi over 4. That's a little bit hard to see considering I'm not graphing right there, so I'm going to go ahead and graph this vertical asymptote to the right pi over 4, which is 2 tick marks. So I'm going to put that right here. And then I can see it's every 4 tick marks that I have a vertical asymptote, so I'm going to go 1, 2, 3, and then 4 more. And then 1, 2, 3, and that makes sense that the last one would be there because we just said that this one would be at negative pi over 4. But negative pi over 4 is outside my window, so I'm not going to graph that one. Okay? But what I do know is that I've got a center point in between, so right there. And then the 2 out front tells me how high and how low. So that means go to the left and up 2, and go to the right and down 2. and then I'm just going to use this as a pattern. So we've got repeat. So this point is the next point before it, so right there, and then 2 over is the center point, and then 3 over is that point, and that's all we're going to see. So my graph looks like this. And that would be my wave. Not gonna lie, that one's kind of an interesting one. I'm not gonna do a flip over the y on your test, because that makes it a little bit more confusing than I'm wanting to make it. So as long as you know how to find period and phase shift and figure all that out, then and flip over the x, then that's fine. But I'm not gonna make you flip it over the y. Okay, so let's talk about this one, or the inverses anyway. Okay. When we have these trig inverse problems, just remember that sine, so little reminder, sine inverse always equals an angle, okay? Because it's like sine of an angle equals a ratio. So if you take sine inverse of both sides, then it's theta equals sine inverse of the ratio. Okay, so one thing to remember is that as far as like y values go, you can like sine inverse the function is one that, let's see, let me remind myself. So sine does this, so it does this. Okay, so sine inverse looks like that. And the thing to remember is that you can plug in numbers between -1 and 1, and you get numbers between -pi over 2 and +pi over 2. So sine inverse is the one that is one of the ones that's only gives you y values between -pi over 2 and pi over 2. Cosine inverse is a function that looks like this. And so you can, again, only plug in numbers between -1 and 1, and you only get answers between 0 and pi, where that's pi over 2. Which is why cosine inverse, when we think about the unit circle, we think only from 0 to pi. And then tan inverse is the function that looks like this, and it's got vertical asymptotes at -pi over 2, vertical, horizontal asymptotes, it has vertical normally, at -pi over 2 and +pi over 2, just like the vertical asymptotes in the regular tangent. And so again, you can plug in any x value into tangent, but you only get y values between -pi over 2 and pi over 2. So -pi over 2 to +pi over 2. Okay, so keeping those in mind, we're going to answer these questions. Sine inverse of -1/2 means it equals some angle. So I'm really asking myself, -1/2 is sine of what angle? So if I look at my unit circle, or remind myself of my unit circle, I know that sine is only negative, like I've only got the first and the fourth quadrants as options. Sine is, let's see, that's 1, 0, so sine is -1/2 at this coordinate point right there, or this angle right there. And so that angle is going to be -pi over 6. So the answer would be -pi over 6. Okay. Number 14, I've got tan inverse of -square root of 3. So again, I'm trying to figure out -square root of 3 equals tangent of what angle. And again, tangent, just like sine, is only the right-hand side, and tangent's only negative in the bottom quadrant, so we're going to look at that again. So I know it's either this one or that one, just because the middle one is square root of 2 over 2 for both, and so tangent is 1, or -1. So again, this is 1, 0, so this is 1 down 1/2, and then square root of 3 over 2. Which means this is 1/2 and -square root of 3 over 2. So when I think about tangent, tangent is sine over cosine, yeah? So sine over cosine, sine over cosine. Sine here, or tangent here, is -1 over the square root of 3, whereas tangent here is -square root of 3 over 1. So when I think about which angle gives me -square root of 3 for tangent, it's going to be this one right here, which is -pi over 3. So that's my answer. negative pi over 3. Okay. Number 15. So number 15 is tan inverse of negative square root of 3 over 3. Or negative square root of 3 over 3 equals tangent of what angle? So if I look at this over here again, tangent is only negative in the bottom right quadrant. Well, for where tan inverse exists, right? So when I go back to my options, tangent was negative square root of 3 at negative pi over 3. But this negative 1 over the square root of 3 is negative square root of 3 over 3. And so that answer would be at negative pi over 6. Okay. Cosine inverse of negative square root of 3 over 2. So negative square root of 3 over 2 equals cosine of what angle? Keeping in mind cosine inverse will only give me values from 0 to pi. So cosine is positive over here, so I know these are my options right here. I know it's not the middle one because that's square root of 2 over 2. So again, I'm going to remind myself this is negative 1, 0, so that means this is 1/2. And then positive for the y value, which means the x is negative square root of 3 over 2. So 0, 1, which means at this angle right here, we've got negative square root of 3 over 2 as the x. I'm going to make that a little bit larger. So negative square root of 3 over 2, comma 1/2. So the cosine is negative square root of 3 over 2. This angle is just 5 pi over 6. So the answer is 5 pi over 6. Okay. I'm going to come back to number 17 in just a minute, but 4/5 is not on my unit circle as far as like one of the known ratios, so I'm going to come back to that one. Alright. Secant of tan inverse of the square root of 3. So secant of tan inverse of the square root of 3. So first off, let me just think about this. Tan inverse of the square root of 3 equals some angle, just like we did up here, right? This equals some angle, and the point was to find the angle. When I found tan inverse of negative square root of 3, I found that the answer was negative pi over 3, which was down here. So it's going to be the same thing up here at positive pi over 3, where I've got tangent is, or sine is, or cosine is 1/2, and sine is square root of 3 over 2. So tangent of what angle equals square root of 3, and that's going to be at pi over 30 up here, square root of 3 over 1. So this right here is pi over 3. Well, then you're supposed to find the secant of that. Okay? So once you find what at what angle tangent is square root of 3, then you can find the secant of that angle. And so if I go up here, secant's reciprocal of cosine, so cosine is 1/2, then this is 2. Alright, one more. Cosecant. Now this is not an inverse, so it's just straight up what is it, right? So let's go to negative pi over 2, which is down here. And this coordinate point is 0, negative 1. Cosecant's the reciprocal of sine. So if I go to the backwards pi over 2, and I get sine is negative 1, then cosecant is 1 over negative 1, which is still just negative 1. So this right here is negative 1. Well, then I'm supposed to figure out what is tan inverse of that. Oh, I should have boxed that. Okay. So tan inverse of negative 1. So what I'm going to do is I'm going to think, where does tan inverse exist, or what y values, and that's from negative pi over 2 to pi over 2. And as far as like getting negative 1, so this is equals some angle, right? So negative 1 equals tangent of what angle, right? Well, here's what I know. I know that tangent is 0 here, undefined here, and undefined there. And it's 1 whenever you get something divided by itself. So at pi over 4, tangent would be 1, which means at negative pi over 4. Because this is a positive square root of 2 over 2 divided by a negative square root of 2 over 2. Or I guess a negative divided by a positive. Either way, you get negative 1 down there, so the answer is going to be negative pi over 4. Okay? Number 17 is a little bit different in that it's not in a unit circle, so we're going to think this out separately. So I'm going to separate this. Sine inverse of 4/5 equals some angle, which means 4/5 equals sine of that angle. So what I'm going to do is I'm going to draw a triangle, and I'm going to label the central angle, and I'm going to let sine be 4/5, so sine is opposite over hypotenuse. This means that's a 3, 4, 5 triangle if the hypotenuse is 5 and one of the legs is 4. So all of this equals some angle. So your job is to find cotangent of that angle, right? Well, cotangent is adjacent over opposite, because tangent is opposite over adjacent. So adjacent over opposite, and that is your answer. So sine inverse equals some angle, which for which it is true that sine of the angle is 4/5. So we drew a triangle where sine is 4/5, and then we're supposed to find cotangent of the angle for which sine inverse equals 4/5, and there you go. Okay, last one on this page. I'm supposed to find cosecant of this expression, which is just some angle, for which it is true that 2 square roots of 13 over 13 equals sine of the angle, right? So if all of this equals theta, then I take the sine of both sides. Just don't forget that this right here is just the rationalized form of 2 over the square root of 13. So that makes it a little bit easier to deal with. So this is just the rationalized form of that. So if you worked it this way, you would not get it wrong, but this is a little bit easier. So what I know is that all of this equals theta, for which sine of theta equals 2 over the square root of 13. So I'm going to draw a right triangle. Sine is opposite over hypotenuse. And then I need to find the adjacent, potentially. Or do I? Because it says find cosecant. So cosecant is of the angle. Cosecant of the angle is the reciprocal of sine. So if sine is 2 over the square root of 13, that means cosecant is square root of 13 over 2. And so there we go. Now, all we really, like, if we had to find that side, we could do a squared plus b squared, which is 2 squared, so 4 equals c squared, and square root of 13 squared is 13. So a squared would equal this 9, which means a would equal 3. So if we needed to, we could have found that. But as it is, all we need is the reciprocal of the sine, and if sine is 2 over the square root of 13, then this is square root of 13 over 2. And there we go.